Okay, hello Year 10. I hope you're all getting on okay, even though we're not at school. What I wanted to do is do just a few little videos which hopefully might help you with some of these areas of the course that you haven't done yet. Please give me feedback if you think it's useful. Drop me an email so I know whether or not to keep doing them. So the first topic I want to do is something called momentum. Now you've probably heard of the word momentum before, but you may well not know exactly what it means. You can see there up on the screen, there is the definition for momentum. So momentum is a measure of how difficult it is to stop a moving object. So if you've got something that's moving and you want to stop it, you've obviously got to apply a force to that, but momentum sort of tells you how difficult it's going to be to stop that moving object. So if we think of the things that are going to affect how difficult it is, you've got two things that are going to affect that, and that basically leads us to our formula, and this is one of the formulas that you need to learn. So this is our formula then for momentum. Okay, so we've got momentum equals mass times velocity. Okay, there it is, quite a simple formula to use. We better just have a look at the units though, as always. Hopefully you are already telling your computer screen what mass is measured in. As you know, mass is measured in kilograms. As you know, velocity is measured in meters per second. So all we really need to do then is look at the unit for momentum. Now it's a bit of a weird one, but actually is very, very logical. Mass in kilograms times velocity in meters per second means that momentum is just measured in something called kilogram meters per second. Okay, as simple as that. Now, as always, I normally just mention doing this in symbols. It's a weird one, this one. I would advise you don't do it in symbols. I'd advise you just keep it in words, simply because momentum is given the symbol small p. Don't really know why, but it is. Equals mass times velocity. There we go. So there it is in symbols if you want it in symbols. Okay, let's have a look then at a few examples of this, I guess, and just go through how you would work this out. So we'll start off with a reasonably straightforward one. Okay, so actually what I'm going to do, I'm going to keep that formula there so we can still see it. Okay, so let's just say then I want to work out the momentum of this shark. Also making these videos has given me an excuse to dig out some old Lego. So this shark then, I'm going to tell you, has got a mass of 500 kilograms. And our shark is swimming along happily here, looking for something to eat at 7 meters per second. Okay, so if we were given a question, calculate the momentum of the shark, it would be as simple as doing, remember, writing out the formula like we always should. Momentum equals mass times velocity. So that in this case is going to be 500 times 7, which, unless I've forgotten how to do maths, is 3,500, and our unit kilogram meters per second. Okay, quite straightforward. Sorry, you can't quite see the end there. There we go. And that's all very well. There is a slight complication that we should probably just check though. Because the formula, as we see up here, has got velocity in it, okay, momentum is a vector. Now hopefully you remember that means it's got a direction as well as a magnitude or size. It's not a massive issue here. Our momentum here is still 3,500 kilogram meters per second, but I suppose if I'm being really, really picky, it should be 3,500 kilogram meters per second to the right. I'm giving it a direction there because momentum is a vector. Okay, we could do another example then. Let me just clean the board off and we'll have another example. All right then. So another example then. Let's say that I have here an octopus. Okay, I've got a limited selection of animals to work with here. So here we've got an octopus, and this octopus has got a mass of 15 kilograms, and it's moving along. I know it doesn't look like it, but it is at a speed that we don't know. That's what we're trying to work out. But I do know though that its momentum, I'm going to say its momentum is 45 kilogram meters per second, and we want to find the speed. So, as always, I'm going to use exactly the same process as I would with any other equation. I'm writing out the formula as I know it, as I've learned it. So momentum, I'm going to run out of room here, mass times velocity, and then I'm going to substitute in the numbers which I know. Now, I've said this before to you in lessons, this is how I recommend you do it. You put the numbers in as you know them. So momentum here is 45 equals mass is 15 times velocity, that's what we're still trying to work out. Well, now we can see from this 45 equals 15 times velocity, so that means that velocity equals 45 divided by 15, which is 3 meters per second. Remember the reason I say do it like this. First of all, you're less likely to make mistakes, but secondly, that would be a mark in an exam for putting the numbers in correctly. So even if you then rearranged it completely wrong, we've still got ourselves a mark. Okay, now that's the basics really. That's all you pretty much need for this particular session. Just one little thing I just want to mention, and just a few examples of, and that is if you're trying to work out the total momentum of a few different objects. So we'll start off then. Two sharks, okay, and I'm going to say that, just to make it easier, they're both 500 kilograms. They're pretty similar there, you can see. And this one here, we'll say, is moving along at 7 meters per second, and this one here is moving along at 5 meters per second. And if I wanted to find the total momentum of these two, what I'm going to have to do, I'm just going to push that up there so you can see, but I want to work out the total momentum. It is very, very simple. Okay, so momentum equals mass times velocity. So for shark number 1, mass is 500 times the velocity, which is 7. And then I'm going to add shark number 2. Mass is 500 times velocity is 5. So that was the one I had before, 3,500 plus 2,500 there, which is 6,000 kilogram meters per second, remembering my direction going to the right. Okay, pretty straightforward there, I think you'll agree. Okay, this next one may be one slight complication. We'll go for, here, some dogs. There's a dog, there's another dog. Okay, dog number 1 over here. 10 kilogram dog, and this here is a 6 kilogram dog, even though they look exactly the same. Funny that. Right, this one is moving, it's running this way at 1 meter per second. Okay, and this one is moving this way at 0.5 meters per second. Again, I want to work out the total momentum. Now, this is where we have to be quite careful. Let's look at the momentum of dog number 1 here. So I'm going to use my formula again, mass times velocity. So that's mass 10 times 1, which is 10 kilogram meters per second. This dog over here, mass is 6 times 0.5 is 3 kilogram meters per second. Now, you may well go, well, fine, the total's 13. I hope you're all telling me now, no, that's not right, and it isn't right. And of course, that's because we've got to look at the directions. Think back to when we were doing forces. It's exactly the same as this. Okay, I've got 10 kilogram meters per second, but that's 10 kilogram meters per second going to the right. This is 3 kilogram meters per second going to the left. And so if we look at that like we did when we were working out resultant forces earlier in the year, if I actually look at that, taking into account the direction, because they're in opposite directions, I'm going to do my 10 minus the 3. It's almost like we're trying to find a resultant momentum. Remember that word resultant just means like overall. So that gives me then 7 kilogram meters per second to the right. Okay, now I hope that makes sense. For those of you who are feeling really confident with this sort of thing, actually, you could have just right up back at the start here said, well, because this is moving to the left, I'm just going to say that the velocity is negative. 6 times minus 0.5 would have given you minus 3. Okay, if that makes sense to you, fine, use it. If you're thinking, what did he just say? Then forget about that. Just look at this basic idea of looking at the directions. And because they're in opposite directions, we know we've got to take one away from the other. Okay, that leaves me to do one final example, and then it's up to you to do some questions. Okay, I think I'm going to need the whole board for this one. This is yet again another one of those total momentum answers, but it's going to bring in a couple of certain ideas. So we'll bring our octopus in again, and this time the only animal I've got left here that I can find is a crocodile. So we've got an octopus and a crocodile. Now the octopus, nice and usefully, well, we'll say it's the same octopus as before, which I think had a massive 15 kilograms. I can't actually remember, but and the crocodile, 200 kilograms. Crocodiles are actually got quite a big mass. Octopuses don't. Not really to scale either, to be honest. Anyway, that's not important. The octopus here is not moving. Okay, that's going to make our life nice and easy. So that's not moving at all, 0 meters per second. However, our crocodile is. Our crocodile is moving this way, and it's moving this way at 10 kilometers per hour. Okay, now, first thing, and this is why I put this in really, 0 meters per second, it's not moving. That means our momentum of the octopus is definitely 0. Anything not moving, no momentum, 0 kilogram meters per second. So that's easy. So actually, all we've got to concentrate on then over here is our crocodile. Now, you might just go, well, it's 10 times 200, that's 2,000. Give you a second just to think about why that might not be right. Hopefully what you've all just said is, well, the reason that's not right is this, kilometers per hour. Can't do it in kilometers per hour, we need this in meters per second. This is a good chance just to look at, in general, how we convert units if we need to. So, the first thing I want to do is convert this 10 kilometers per hour into meters per second. Now, there's no way just to do it straight away, we've got to do it in steps. So, kilometers. K for kilo meaning 1,000. So that means this, 10 kilometers per hour, that means 10,000 meters per hour. Okay, so that means that our crocodile here goes 10,000 meters every hour. Okay, so that's meters per hour. Obviously, we want meters per second. So the next sort of step would be to think, well, if it's going 10,000 meters per hour, how many meters is it going per minute? Okay, so let's divide that 10,000. Actually, we'll write it out properly. So we'll do our 10,000 divided by 60. Okay, and that's going to tell me then how many meters it's going to go per minute. Okay, now I forgot to get a calculator out before I did this. Let me just find that now. So 10,000 divided by 60. Okay, that gives me about 167 meters per minute. And then I take my 167, divide that by 60 again, and that will tell me how many meters I'm going per second, or my crocodile is going, and it gives me 2.8 meters per second. Okay, so you see the steps. We're going to meters per minute first. Well, first of all, sorry, to meters per hour, then to meters per minute, then to meters per second. So my final step then, my momentum is going to be mass, which is 200, times by my 2.8, and that gives me about 500, if I round it, 556 kilogram meters per second. Okay, I hope that has been helpful to you. If it has been, please let me know, and I'm very happy to carry on doing this as we go through the topics while we're not in school. Okay, so stay safe. I will see you on the next video.